Yo, Chuck.
What the chuck is up, YouTube? In this video, we're going to go over counting sort. Counting sort is a sorting algorithm that uses key value pair logic to sort numbers in ascending order. The first part of this video will be dedicated to a visual representation of just how counting sort works, and then I'm going to do a live coding session and give you a nice code example of how to code out counting sort. This should be a fun video, so let's get started. So like I mentioned, counting sort will use key value pairs to sort data in ascending order. The first thing we need to do is look at our initial array here. We can see it's unordered and there's duplicates of certain items. There's 2 2s and there's 3 1s, for instance. What I actually need to do first is find the max value in this initial array. So I'm scanning the array. I see 4 looks like it's the max value, so I'm going to write 4 is the max. From here, I need to create a new array. I'm going to call it countArray, and it needs to be 1 greater than 4 because I need that many indices. I need 5 indices to encapsulate all the data that was spewed out in my initial array. Why am I doing that? Because I need to account for 0. That's why we're adding 1 plus the max of 4. So now I have all these buckets. I want you to imagine this count array is just those 5 indices, and they are just representing buckets where I can now place the data of my initial array. So I'm just going to scan through my initial array and place these numbers and their respective indices in the count array, and then keep track of the frequency of those numbers. So the first thing I would do is look at 3. I'd say 3 goes in the 3 bucket, so I'm just going to increment it by 1. Then I will look at the next number, which is 2. I'm going to place 2 in the 2 bucket. I'm going to go to the next number, which is 1. I'm going to place 1 in the next bucket. I'm going to go over to 2 again. Oh, we already have a 2, but that's okay because I'm just keeping track of the frequency using this counting array at that index. So I'm just going to increment this 2 one more time. And I'm going to continue doing the same thing for these other numbers until I finally reach the end of the array. And now my counting array is in a good place because it has all the indices that I need, and it has a frequency amount for each number. And it's stored, each number is stored at its respective indices. Okay, so now we're in the counting array. I can actually just loop through the counting array, and if the number is greater than 0, I can put it out in my sorted array. So I'll start at index 0. There were no zeros in my initial array. Therefore, there is no value to spew out into my sorted array. So I'm just going to skip this. I then reach index 1. I see there's 3 in index 1. Okay, so I'm going to draw 1 out of the bucket, like so. And now I can decrement 1. Again, there's still greater than 0 numbers of 1s in here, so I'm going to decrement again, just like that. And I'm going to do this until I reach 0. So now I've reached 0. Okay, I am no longer going to mess with this index. I'm going to now increment to the next indices, which is 2. So I'm going to do the same thing. I'm going to put a value of 2 in my sorted array and decrement the 2 indices on my counted array. All right, and then do the same thing again. Now that it's reached 0, this bucket has reached 0, I'm going to move to the next bucket, which is 3. Repeat the process again, and then finally land on 4, and then repeat the process again. So you can see, just by using these indices, which are naturally sorted anyways, I can store numbers at a specific frequency, and as long as that indices has a number greater than 0, I can shoot it out to a sorted array. And what this does is it automatically sorts because arrays by default are sorted, 0, 1, 2, 3, 4, 5, 6. They're in ascending order, so it already does the hard work for us. We just need to keep track of how much is in that specific bucket, and then if that bucket is greater than 0, we'll shoot it out to our sorted array. So that is how counting sort works conceptually. I want to now jump into a coding example. Okay, so the first thing I'm going to do is just make a function called count in sort. And that's going to take an array that's unsorted. Then I'm going to console.log the function call of counting sort. And let's add a unsorted array with duplicate values to illustrate the bucket concept that we were talking about before. So we'll just do something like this. Completely random and unsorted. Okay, cool. Let's return the array to make sure it fires. If I run this code, we can see we have an unsorted array. Excellent. So just like I said in the previous visualization lecture, we need to find the max value of that array. We can do that by making a for loop and searching for a max and then changing the max depending on the greatest number seen. That's kind of intensive and a lot of work. Or we can just do something like this. Make a variable called max, utilize the math.max function in JavaScript, and use array destructuring here. And that will do the same exact thing. So let's return max to see what it is. And it looks like that is 5. Okay. So just like I said before, we need to create an array that is 1 greater than our max because we need 6 indices to encapsulate all these values. And the reason we need 6 is because, recall, arrays always start at index 0. So you need 0 through 5 indices to properly do this algorithm. That is 6 total indices. So let's make an array called countArray. And that is just going to use the array method from JavaScript, which creates a array, and then you need to specify how many indices it's going to have. We want max plus 1. Let's return the count array and see what it looks like. Excellent. You see there's 6 empty items waiting to be filled. So now we need to place these items in that count array. So the way we're going to do that is we're just going to loop over those items firstly. I'll set I equal to 0 as long as I is less than array.length. Increment I. So I'm going to loop over each item and then place it in its respective index. So I'll say if count array at indices of array at I. So if that doesn't exist, so it's null or it just hasn't been specified as a value, then I want to set it equal to 1. So I'll say count array at index I equals 1. Okay? Or actually I'm going to say it equals 0. So I'm going to instantiate it here so it equals 0. And then I'm always going to increment that value by 1. So this is going to give us that key value pair relationship that I was talking about before, where we're placing the number at its respective indices in our count array, and then we're keeping track of the frequency of that number, which is just how many occurrences we've come across when we loop through our entire array. Let's see what that looks like when I return it. Return count array. Okay, so as we would expect, we have no 0 in our array, so that's empty. But notice we have 2 1s, 2 2s, 3 3s, 1 4, and 2 5s. Does that look correct? If I look at this, I do see the 3 3s, I see the 2 5s. That looks correct. So really what you can say about our count array is it's just keeping track of the frequency of the numbers in our unsorted array at their respective index. Okay, so now that we've done that, we need to make a result or a sorted partition array. So I'm going to say const result equals an empty array. And this is going to be where we put our sorted values into. Okay, so I'm just going to do another for loop now. Same type of logic, as long as I is less than countArray, because I want to loop through the countArray now. We're going to increment I. Okay, so here is kind of logic that might trip you up. Maybe not though. We need to have, as long as this value is greater than 0, we're going to loop over every individual value in our countArray. And as long as the values are greater than 0, we're going to shoot them out into our result array, but we have to decrement this indices every time we do it. So I'm going to say while count array at indices I is greater than 0, we need to decrement that indices, and we want to push whatever that indices is to our result array, because that is going to be sorted in the end. So I'll say result.push, and I'll do I here. And now if I return this array of the result, you can see we have a sorted array. And that is the secret behind counting sort. It's really not that complicated. We're just using those indices to store our values. And by nature, arrays are already sorted indice-wise from 0 to whatever you specified as the last element in your array. So there you have it. That is counting sort. Oh yeah, and one more thing. The time complexity of counting sort is O of n plus k, where k is the range of values you choose from. So this is better than just plain up O of n squared, obviously, but it's not as good as O of n, which is linear time. And the reason it's a little bit worse than linear time is not only do you have to go over the whole array at least once, you're having to do this looping right here, which depending on the frequency of each indices is going to slow you down a bunch. So that is worth mentioning. But yes, that is the counting sort video. I hope you guys enjoyed this, and I will see you in the next one.